Hi class, welcome to another module in CS384. This time we will be looking at an important piece of knowledge which is multi-threading, right? So as we see the word multi-threading, so multi means multiple, and we will see a new term which is known as threads, right? So this term is basically taught in the operating system concepts, right? But since you haven't studied an operating system, so let me just go through a very brief basics, right? So everybody know their task manager in Windows and everything, right? So whatever you're executing, we have Visual Studio, PyCharm, PowerPoint, etc. You can see here PID is there, process ID, and there is also a process name, right? PowerPoint is having PowerPoint.exe. This is my screen recorder. I have Dropbox also. You can right click here and just ensure that PID is checked, right? By default, PID is not checked. So if you are on Windows 10 system, just right click here and check PID. So what happens? Every process is identified by a process ID. Process ID is like the OS mapping of the process, right? So just assume like OS provides a roll number to every process that is running, right? And that is unique. So in all the process that are running here, there will be no two process having the same PID. They cannot, simply cannot, right? Just like every roll number, every process has to be a unique ID, right? So now when everything can be executed by a process, then why do you actually need a thread? What is the concept of a thread? So thread, sometimes wherever you read, even if you ask any computer science guy, they will just give one line answer. Thread is a lightweight process, right? So now just forget about what is a lightweight process, how do you define the process in the memory, leave about those data structures. I will just give you a simple example, right? How to visualize threads, right? So let me just give an example. Let's say, okay, this is a course on Python, right? Course name is CS384. First example I would like to share with you is like, for example, when I'm writing this file, right? So as everybody knows, this is a word processor, right? This is Microsoft Word. So you can see this process has come. The process ID is 5584. The process file name is winword.exe. Okay, fine. So this is a process. But if you see in the bottom of this, you can see there is something called like page one of one. I'm on the first page. There are 10 words in the document, right? Let me make a simple spelling mistake. Let's say I write the name of Joker as Jker, right? So it says me, okay, the spelling is wrong. It gives me a possible suggestion also, right? So you can see that there are many things that are executing in the backend, right? There is some process which is counting the word in the background. There is some process which is actually keeping a track of what is the page number where my current document is. There is a process that is keeping which language I'm using in the document, right? So what any process does in order to improve its performance, they make use of threads. Now you may ask, why don't we use process exactly, right? See, whenever you are starting word, right, when the word is under execution, only then the page number and this words and this language, all these will be having some weightage or basically having some meaning attached to it. Let's say when I close word, right, when I close words, these things will automatically close, right? These will not stay on the screen and record page numbers and words in other documents. These are specifically for Microsoft Word, right? So what happens with the thread is like they execute only when the parent process executes. Parent process as in, so when I start Microsoft Word, all these things will start along with it, right? So Microsoft Word, as you can see in the task manager, is the main task having the process ID 5584. It may be a different ID in all your on your system. And along with that, in the backend, it will start these threads, right? So whenever you start a major process, there are so many backend threads that run along with it that we cannot see in the normal task manager, but there are tools and softwares with which you can see each and every thread that is being executed. Now what are the advantages of thread? Advantages of thread is, for example, I will write a very small piece of code that will just give me the page number on the document I am working on. Like for example, I will just write a very small code that will count me the number of words. See, now you all know Python quite well. So if I ask you to write a small Python program that will count the number of words in a given document, you can easily do using regular expression, right? So the advantages of threads are that they are small process only. There are small executable files that do very small tasks, right? So one advantage is that since the code is very small, handling and maintaining the code becomes easy. Second thing, now let's say for some reason your code has a bug here and it crashes, right? So basically this thread crashes. So you need not worry about other threads, right? Other threads will execute independent of this particular thread, right? So your whole program does not crash. If you write a very big exe file that does everything, so your entire process will crash, right? Sometimes we see that not responding, not responding, not responding, right? If you are a gamer, which at your age you play a lot of games, so assume like when you are playing, let's say FIFA or PUBG or any other game, so there is a thread that is executing the sounds in that game. There is a thread that is executing, so whenever you press a particular key combination, you are getting a super boost or performance boost, right? And similarly there is a thread that is navigating, right? When you press the forward key, something is getting navigated, etc., etc. So you can assume that every process, for example, in a web browser, there is a thread which is basically rendering the audio, a thread which is rendering video, a thread that is maintaining communication between the client and the server. Fine. So this is the concept of a thread, right? So when we execute the code, we will get an idea more about what is thread and everything. So let us see a program here, right? So just bear with me. So in this first program, I'm importing threading. So threading is a module in Python, right? Import os.system clear. I think everybody knows now. Okay, so I'm defining a function which says print hi, and it is accepting a single parameter num, right? So basically you will not get a feel of thread. I'm just showing this program how to define a thread. So I'm just saying print you are a customer number, and I'm putting the number which the user will enter, and I'm also getting the thread name, right? So this syntax is bare. Like for example, I'm importing the threading library. So threading library has a method current thread, and within that I'm calling another function to get the name. Okay, so now you can see how do I call thread. So in the main function, I am saying, okay, currently executing thread. I am getting the name of the thread. And this is how I define a thread. So the module name is threading. So threading dot thread. So you can see thread is a method itself, right? So the unique thing about the thread method is that it itself is a method, right? You can see this parenthesis here and the target to it. So this method accepts a method, right? So if you see, I have a definition here, print hi. So you can see the target is equal to print hi, right? So in the target, I'm specifying the target function that needs to be called via thread, right? So just bear with me, and I'm passing on the arguments separately. See, the print hi function, if it would not had been a thread, I would have just called it like this, right? I would have just called it like this, writing the name of the function and let's say passing the argument, let's say 100. But since now I want to execute it as a thread, I am invoking the threading module and passing it to the thread method and saying it, okay, I need to call the print hi function and with the argument 75, right? So and then I am having t1 dot start. So basically I am assigning this function to be executed as thread t1. Similarly, then I'm calling t1 dot start and t1 dot join. Now what is start and join we will see later, but now let us just execute this code. So you can see we have some output here, print current executing thread, right? So whenever your program, see this is your main execution, right? So your main program execution is named as main thread, or you can say as parent thread. As like for example, when you execute Microsoft Word, so and you see it in the task manager. So in the task manager, you can say when word is the main thread, fine. And now you can see I am calling the target print hi, which is nothing but this definition, and I'm passing the argument 75, which gets copied into num automatically. Right? I can even specify num1, num2, num3. Then it will be 75, 85, 102, -2, something like that. Just that same mapping like we do in definitions. Okay. Now when I'm calling this threading method, so this is not a normal invocation. Now it calls the function print hi using a thread, right? So hi, you are like your customer. So hi, you are customer. 75 was passed, so this is 75. And now you see this, see the same syntax, right? Threading dot current thread dot get name, threading dot current thread dot get name. But you can see when I executed this statement in the main, it gave me main thread because that was the main program under execution. Now this main thread, within the main thread, I'm calling another thread, right? So see, the name of this thread is given as thread 1. So it executes this, exits the function, and returns to the main and then prints an end, right? Now your obvious question will be, what is the difference between this? If I would have executed this code with a simple method name, it would have still got executed, and you are absolutely right. But just to get a feel, you can get a feel of main thread and thread 1. We will again see further examples to get a clearer picture, right? Start and join, right? Instead of join, Python could have used a better word like, end, but of course there can be multiple threads, so they have used a keyword join. T1 dot start means, see, at this point you are just defining the thread, right? Even though the target is print high, at this point it does not get called. When you say T1 dot start, now basically the T1 thread will call the print high function. Here it is just like an initialization key. Okay, the moment I get executed, I need to call the print high function. Okay, so the moment you say T1 dot start, the thread will execute and call this function. Now T1 dot join means, once you start the thread, I need to wait till the thread successfully executes. We will see this example in the next video. For right now, just say that, okay, whenever you are starting a thread, you also need to join the thread so that it is ensured that the execution is complete. So that's it for this video class. Have a good day.